Okay, let's talk about a couple more things. Now, we've talked about triangles that are similar. And in triangles that are similar, there are two things that are true. What are the two things that are true? Okay, knowing that those two things are true, what we need to do is we need to talk about a couple other things that are true. First of all, if I have triangle ABC and triangle DEF, and those two triangles are similar, what I can say is altitudes. Altitudes, of course, go from one side and make a right angle with the opposite side. In both cases, corresponding altitudes, so the altitudes from the same type of angle to the same type of angle, are also going to be similar. So A, B, C, D, E, F, G, H. So what I would say is I would say BG would be proportional to EH. Okay, BG to EH. Now, this is also true of something that when we cut this angle in half, so this angle and this angle, and if I do the same thing to this, when I say this angle to this angle, we would say that these are what? What are these things right here? Well, of course, they are angle bisectors. So angle bisectors would be also proportional. So if two triangles are similar, their angle bisectors are also going to be proportional. Now, if I got altitudes, I got angle bisectors, what's the one that's left? That's right, medians. And so medians, remember, go from one thing and they cut the opposite side in half. So we cut this side in half. So here we go, cut this side in half. You'll notice these are double marks because they're not the same length as this, but they are equal to each other. And so we would say A, B, C, D. So we got G here and I got H here. And I would say BG is proportional to EH. Okay. So it's not really shocking that in triangles, if all angles are congruent and all sides are proportional, that the altitudes will be proportional, the angle bisectors will be proportional, and the medians are going to be proportional. So we have those. Now, this is a little bit of a weirdo. It is true, but unlike this where we have one triangle similar to another triangle, we start with two different triangles. Here we're just going to start with one triangle. I have one triangle, ABD, and what I'm going to do is I'm going to draw an angle bisector here. So this angle and this angle would have to be congruent. If we have an angle bisector, it takes and it splits the far side into proportional pieces so that BC is going to be to CD. It's going to be proportional. Okay, but what it's going to be proportional to is this and this are going to have the same proportion as this and this. So I'm going to say BC is to AB. So this goes with its partner as CD goes with its partner, AD. Now, let's say that we know that this side over here is 2. I want to be able to find X. So I say, well, first of all, is it an angle bisector? Yes. Then this has to be proportional to this. 2 is to 4. As what is to what? Well, X is to 6. And so now we cross multiply and we come up with 4x equals 12 and x equals 3. So this is the triangle angle bisector. Triangle angle bisector. If you have an angle bisector, it splits the opposite side proportionally in relation to the other two remaining sides. So 2 goes to 4, x goes to 6. So nothing terribly shocking there. In fact, it makes for a nice short section.